Now let's take a look at number 12 from chapter 1 of our book. Here we are going to develop a model for total cost. We're also going to calculate profit and calculate a break-even point. So we are dealing with a shoe manufacturing company that's willing to produce a special style shoe if the order size is large enough to provide a reasonable profit. We're told that for each special style order, the company has a fixed cost of $2,000, a variable cost of $60 per pair of shoe, and each pair sells for $80. So in part A, we are going to let the variable X indicate the number of pairs of shoes sold. We need to develop a model for the total cost of producing X pairs of shoes. So we need to figure out the total cost. If we don't know the total cost, or that's what we're after, we can insert TC to stand for total cost for the moment. So total cost, we know from our notes and our reading, total cost equals the fixed cost plus the variable cost. But remember, the variable cost is per pair of shoe. So we multiply that $60 times the number of pairs of shoes. Now we can insert the values that we've been given. We know that our fixed cost is $2,000 plus the variable cost of $60 times the number of pairs, and in part A, it says let X indicate the number of pairs. So total cost equals $2,000 plus $60 times X. Part B says let P indicate the total profit. Develop a model for the total profit realized from an order of X pairs. So now we need to calculate the profit, and we know that profit equals our total revenue less our total cost. So our total revenue is $80, but remember, $80 per pair. So $80 times X minus the total cost, which we just calculated above. So minus 2,000 plus 60 times X. Be very careful here. Total cost fits in this whole set of parentheses. If we take those parentheses out, we need to distribute our negatives. So we subtract 2,000 and we will subtract the 60x. So doing that, or getting rid of those parentheses, means we have 80x minus our fixed cost of 2,000 minus 60x. Now we can combine like terms, so 80x minus 60x, and we have that our profit equals $20 times the number of pairs of shoes we sell minus our $2,000 fixed cost. That's the profit. That's how much money we will actually end up with in our pocket after paying for all of our expenses. So part C says, what is the break-even point? So that means how many do we have to sell to just break even? It means we don't make any money, but we don't lose any money. So our P equals 0. Our profit is 0. So subbing that into the equation from part B, we have 0 equals 20 times X minus our $2,000. We need to solve for our variable X. We need to isolate that X. So we start by adding 2,000 to each side of our equation. Remember, if you do it to one side of the equation, you also have to do that on the other. So we have 2,000 equals $20 times X. But we don't want this $20 there. We need to get that out of the way. We are just solving for our variable X. So we divide by our $20, but again, you must divide on both sides. So we end up with 2,000 divided by 20 equals 100 equals X. So our dollar signs also cancel, which makes sense because we aren't selling dollars of shoes, we're selling pairs of shoes. So 100 equals X, or our break-even point is 100 pairs of shoes. Break-even point at 100 pairs of shoes. So just to understand this a bit more, if we only sold 99 pairs of shoes, we would lose money. However, if we sold 101 pairs of shoes, we would start to make money.